Welcome to this maths made easy video on function graphs. To start with, let's take a look at graphs of kx to the power of n. Now graphs of this form have the same basic shape, however the values of k and n affect how they look. So let's take a look at some examples now. So for this example here, n is positive and even. So n is positive and even. And we can see the graphs are either U-shaped if k is positive, so that's represented here with this purple curve, or it's N-shaped here if k is negative. Okay? So nothing else really to say about that example, that's just when n is positive and even. If we take a look at two more curves here, this is when n is positive and an odd number. Okay? So here now we notice that the graphs either go from the bottom left, so if we start in the bottom left here, and go to the top right, that's when k is positive, so that's when k is positive here, we've got 4 there, or they start in the top left here, and they go to the bottom right, and that's when k is negative, we've got -2 there. Essentially the graphs go from corner to corner there. Okay, so first let's clear the screen here, and let's get some more examples up. So now, let's take a look at this example here. This is when n is negative, so n is negative and even. Now when n is negative and even, we notice the graphs are mirror images in the y-axis. And we also notice that they're above the x-axis if k is positive, so that's represented with this purple curve here, and below the x-axis if k is negative. Okay. And finally, let's take a look now at when n is negative and odd. So n is negative and odd. So the parts of the graph are in diagonally opposite quadrants. And we notice here in the bottom left and top right quadrants here. These are both for 2 over x, so y equals 2 over x. So these are actually what we'd call reciprocal graphs or curves. So in the bottom left and top right quadrants, this is when k is positive. Okay, so k is positive there. And we notice they're in the top left and bottom right quadrants if k is negative. Okay, we've got -1 there. And we can note here, an asymptote is a line that the curve gets infinitely close to, but never touches. And we can see for the third and fourth graphs, both have asymptotes at x equals 0 and y equals 0. Okay, so we can see that from both of these examples here. So that gives us everything we need there for graphs of kx to the power of n. Moving on now, let's take a look at quartics. So a quartic is a polynomial with an x to the power of 4 term. So we need something with an x to the 4 term as the highest power. Now to sketch a quartic, you will need to find where the curve crosses or touches the x-axis. The expression will usually be factorised, which makes it easier to find these values. Quartics with positive x to the 4 coefficients are positive for very positive and very negative x values. And quartics with negative x to the 4 coefficients are negative for very positive and very negative x values. So for example here, if we want to sketch the graph of f of x equals x squared times x minus 1 times x plus 2. How would we do this? Well, let f of x equal 0 first. So if f of x equals 0, what we can see here is x squared times x minus 1 times x plus 2 equals 0. Now here, if this is equal to 0, we can easily see the solutions here. We notice x squared is a double root, so the graph touches the x-axis at 0. The curve crosses the x-axis at 1 here, x minus 1 equals 0. So it also crosses the x-axis at 1 and -2. So crosses at 1 and -2. And note here we have a double root at 0. So double root at 0. And if we substitute in x equals 0, we can find where this curve crosses the y-axis. So therefore, y is equal now to 0 squared times 0 minus 1 times 0 plus 2. And clearly this would just give us 0. Now, the coefficient of x to the 4 is positive, so the curve will be positive for very positive and very negative x values. And therefore, we've got enough information to sketch this graph. If we put all of this together now, we obtain something of the form here, like this. Okay, so you should get something that roughly looks like this. And again, just highlighting what we've got here, we've got our double root at 0, we've got a cross here, it crosses the x-axis at 1, and minus 2 there. Okay, so that gives us everything we need there for quartics, and that concludes this mass media video on function graphs.